Hello, welcome to a course on Indian knowledge system. In this series of videos, today we are going to discuss the multiple choice questions on number systems and unit of measurement in Indian knowledge system. So let us start with the question. So let us start with the first question. Which Indian mathematician contributed significantly to the development of trigonometry, including the sine and cosine functions? The options given are Aryabhatta, Bhaskara II, Brahmagupta or Srinivas Ramanujan. Points to consider here are Aryabhatta was an ancient Indian mathematician and astronomer who lived in the 5th century Common Era. His work Aryabhatiya is a seminal treatise that made significant contributions to the mathematics and astronomy. Aryabhatta provided tables of sine and cosine functions along with other trigonometric ratios in his work. These tables facilitated calculations in astronomy, navigation, and geometric measurements. Aryabhatta's contributions laid to the groundwork for the development of trigonometry as a distinct mathematical discipline. Therefore, the correct answer, yes, you guessed it right, it is Aryabhatta, option A. Next question is, what is the primary basis of the Bhut Sankhya system in ancient Indian mathematics? The given options are option A, assigning numerical values to Sanskrit vowels, B, utilizing geometric shapes for counting, option C, associating numbers with the phonetic order of Sanskrit consonants, option D, following the decimal system like the modern numeral system. What we must know to answer this question correctly is the Bhut Sankhya system in ancient Indian mathematics assigns numerical values to the Sanskrit consonants, not vowels. Each consonant of the Sanskrit alphabet was assigned a numerical value starting with K representing 1 and counting based on the phonetic order. Numbers were represented by adding the values of their corresponding consonants. This system was non-positional, meaning the order of the consonants mattered, unlike the modern decimal system. With this information, can you guess the correct answer? So, the correct answer is associating numbers with the phonetic order of Sanskrit consonants. Next question is, which of the following numerical notations was not used in the ancient Indian mathematics? The given options are A, Roman numerals, B, Brahmi numerals, C, Gupta numerals, D, Devanagari numerals. Points to consider here are Roman numerals developed by the ancient Romans were not used in ancient Indian mathematics. Instead, various indigenous numeral systems such as Brahmi, Gupta and later Devanagari numerals were prevalent in India. These numeral systems had unique symbols for representing numbers and were widely used in mathematical texts, inscriptions and manuscripts throughout ancient and medieval India. Roman numerals were primarily used in the Roman Empire and Europe for numerical notations and record keeping purposes. The correct answer of this question will be A, Roman numerals. The question that we have now is the concept of shunya or zero as a symbol and numerical value finds its earliest numerical usage in which Indian ancient text? The given options are A, Rigveda, B, Brahmasputa Siddhanta, C, Atharva Veda, D, Bakshali manuscript. What we must know to answer this question correctly is Rigveda is the text that predates Shunya by several millennia and lacks any mathematical context. Atharva Veda, though containing philosophical references to emptiness, it doesn't utilize Shunya as a numerical concept. Bakshali manuscript dates back to 3rd and 4th century Common Era. It possibly uses Shunya, but evidence remains inconclusive. Brahmasputa Siddhanta was written by Brahmagupta in 628 Common Era. It demonstratively uses shunya as a number and provides rules for its arithmetic operations, making it the earliest confirmed usage. With this information, the correct answer of the given question is, yes, you guessed it correct, option B, Brahmasputa Siddhanta. Next question is, how are numerical values represented in the Bhut Sankhya system? The given options are option A, through binary code, B, using prime numbers exclusively, C, by assigning values based on phonetic similarity, option D, with geometric symbols and shapes. Please recall here, in the Bhut Sankhya system, numerical values are assigned to Sanskrit consonants based on their phonetic similarity. This association allows for a mnemonic approach to remembering numerical values. So, the correct answer of this question will be by assigning values based on phonetic similarity, that is option C. Next question is, what was the most widespread and well documented application of the Katyapadi system in the ancient India? The given options are A, representing musical compositions in Indian classical music, B, encoding messages in ancient Indian cryptography, C, recording dates and astronomical calculations, and D, assigning symbolic meaning to the words in literary works. Facts which will take us to the correct answer are, while the Katyapadi system had various applications in ancient India, its most widespread and well documented use was for encoding messages in cryptography. Its ability to convert letters into numbers and vice versa made it ideal for creating ciphers and secret codes. Therefore, what will be the correct answer of this question? The correct answer for this question is option B, encoding messages in ancient Indian cryptography. Next question is, the Katyapadi system is a unique ancient Indian numeral system. How does it differ from other numeral systems like the Roman or Hindu-Arabic systems? The given options are, it uses geometric symbols for numerical representation. B, it assigns numerical values to Sanskrit vowels exclusively. C, it relies on phonetic symbols or words for numerical notation. D, it follows a base 12 counting system similar to ancient Mesopotamian numerals. The points to consider here are, the Katyapadi system stands out amongst numeral systems for its linguistic twist. Instead of symbols or digits, it assigns numerical values to consonants in the Sanskrit alphabet, reflecting their phonetic order. This creates a unique non-positional system where the arrangement of these letter numbers determines the final value, unlike the systems like the familiar Hindu-Arabic one. This fascinating approach highlights the ancient Indian connection between language and mathematics, offering a glimpse into a different way of representing and manipulating numbers. Therefore, the correct answer of this question will be option C, it relies on phonetic syllables or words for numerical notation. Next question is, what advantages does the Katyapadi system offer in representing numbers? The given options are, option A, it enables precise geometric calculations, B, it simplifies complex mathematical operations, C, it facilitates memorization through mnemonic devices, D, it provides a universal standard for numerical notation. What we must know to answer this question correctly is, while the system could represent numbers, its non-positional nature and complexity might not have made it ideal for precise calculations. The system structure wasn't well suited for simplifying complex calculations compared to other options. The system wasn't intended as a universal standard. It had regional and cultural specifications. By associating numbers with words, the system could aid memorization, especially for dates, astronomical calculations, or religious contexts. With this information, the correct answer of this question is, it facilitates memorization through mnemonic devices that is option C. The next question is, what ancient Indian system was primarily used for measuring time, distance and weight? The given options are option A, Bhuta Sankhya system, B, Katyapadi system, C, Vedic numeral system, D, Sulba Sutra system. Please recall here that the Sulba Sutra system is the most accurate choice because these ancient Indian texts provided detailed instructions for constructing Vedic rituals, altars and fire pits. These rituals demanded precise measurements for time, distance and weight, making the Sulba Sutras invaluable for such calculations. While other systems like Bhuta Sankhya and Katyapadi dealt with numbers, they weren't primarily focused on the specific measurement needs for the Vedic rituals. So, the correct answer of this question is option D, Sulba Sutra system. Next question is, who developed one of the earliest documented binary systems in the ancient India, primarily used for analyzing the meter of Vedic poetry? The given options are A. Aryabhatta, B. Bhaskara II, C. Panini and D. Pingala. Facts which will take us to the correct answers are: Pingala, an ancient Indian poet and mathematician from around the 2nd century before Common Era, is credited with developing one of the earliest documented binary systems in India. This system, known as Pingala binary system, utilized binary principles to analyze and classify the complex rhythmic patterns, meters found in Vedic poetry. While other mathematicians like Yajnavalkya later developed binary systems for numerical representation, Pingala's contribution lies specifically in his application of binary concepts to the poetic analysis of Vedic verses. So, the correct answer of this question is D. Pingala. Next question is, which of the following mathematical concepts originated in ancient India around the 6th century Common Era? The given options are A. Calculus, B. Negative numbers, C. Probability theory or D. Graph theory. What we must know to answer this question correctly is, while early ideas related to limits and infinitesimals laid the groundwork for later calculus and probability theory developed independently, the earliest documented use of negative numbers stems from the Indian texts around the 6th century Common Era. Pioneering mathematicians like Aryabhatta and Brahmagupta used negative numbers in the context like representing depths, paving the way for their wider acceptance in mathematics. Graph theory did not originate in ancient India around the 6th century Common Era. Therefore, the correct answer of this question will be option B, negative numbers. Next question is, what is the distinguishing feature of the Gupta scripts numerals originated in 4th to 6th century Common Era? The options are, they used the positional value system, they had separate symbols for 0, they employed Roman numerals, and they were limited to counting small numbers. Points to consider here are, unlike earlier systems like Brahmi numerals, Gupta scripts numerals implemented a positional value system. In this system, the value of a digit depends on its position within the number, similar to the modern decimal system. This advancement allowed for representing larger numbers with fewer symbols. With this much of information, the correct answer of this question will be option A, they used a positional value system. Next question is, both the Bhuta Sankhya and Katyapadi system developed in ancient India utilize specific features. Which of these features best reflects the unique approach they offered to number representation? The options are A. Integration of language and mathematics, B. Use of Roman numerals for counting, C. Reliance on a positional value system, and D. Focus on representing very large numbers. What we must know to answer this question correctly is, the Bhuta Sankhya and Katyapadi system stands out for their distinctive approach to represent numbers with integration of language and mathematics. They were not using Roman numerals, neither they relied on positional value system, and their focus was not on representing a very large number. Therefore, the correct answer of this question is option A, integration of language and mathematics. Next question is, the basic unit of time in ancient India was, the given options are A, second, B, minute, C, hour, or D, nada, that is breadth. Please recall here, while modern units like seconds, minutes and hours weren't prominent in ancient India, nada, the breath, served as their basic unit of time. This concept, deeply rooted in Vedic philosophies, linked time measurement to natural cycles and individual awareness. The duration of one nada wasn't fixed but roughly corresponded to 4 seconds, varying based on breathing rate and context. This unique unit emphasized the connection between inner experience and the flow of time in ancient Indian thought. Therefore, the correct answer of this question is option D, nada, the breath, was the basic unit of time in ancient India. Next question is, during the Gupta Empire, 4th to 6th century Common Era, which of the following units likely played the most significant role in everyday life for measuring small distances such as the width of fabric or the size of utensil? The options given are A. Yojana, B. Hasta, C. Angula, D. Gaja. Facts which will take us to the correct answers are, while various units existed in ancient India, some catered to specific purposes. During the Gupta era, angula, finger width, likely held the most significance in daily life for measuring small distances. Yojana was primarily used for travel distances like measuring roads or pilgrimage routes. It wouldn't be suited for everyday tasks. Hasta was used for larger measurements like furniture or cloth lengths. It might not be as precise for smaller objects. Gaja was used for land area measurement. It wouldn't be relevant for everyday objects. Therefore, during the Gupta Empire, the measurements such as width of fabric or size of the utensils was measured by angula, the option C. Next question is, during India's ancient period, diverse units of length served various purposes. Which of the following was not a common unit used for the measurement in this era? The given options are option A, hasta, B, yojan, C, dhanus, and D, meter. Please recall here, hasta was a unit based on the forearm length. It offered a practical reference for everyday measurements. Yojan was used for measuring long distances like travel routes between cities or pilgrimage spots. Dhanush represented the approximate distance an arrow could travel, relevant for military and hunting contexts. Therefore, the correct answer of this question would be option D, that is meter, was not a common unit used for the measurement in the ancient Indian period. Thank you for watching this video. Stay tuned for more such content.